Hello everyone, this is Mr. Hussein and welcome back. So in today's lesson, we'll be learning on chemical kinetics. So now, let us understand what chemical kinetics is. But before I tell you what chemical kinetics is, I want you to understand something. So in your first semester of general chemistry, you learned how to write or balance a chemical reaction, isn't it? This you learned. But if you didn't learn this, I'll make some videos for you and you will learn. But in your first semester, you learned how to write and balance chemical equations. And using stoichiometry, you learned how to determine how much of the reactants were consumed and how much of the products were formed. But one thing you're forgetting is that you never learned how fast those reactions were occurring. So now, since you never had an idea or you never learned how fast or slow the reactants were disappearing or being consumed and how fast the products were the products were being produced. When it comes to chemical kinetics, that's the area that you focus on. So chemical kinetics is simply the area in chemistry that is concerned with reaction rates. So chemical kinetics talks about how fast or slow a reaction proceeds in terms of how much or how fast the reactants are disappearing and how fast their products are appearing. So now, why is chemical kinetics important? What you have to understand is this: the spontaneity of a reaction has nothing to do with how fast a reaction occurs. If you think of it, if you talk about the term spontaneity, this refers to the tendency of a reaction to occur. Now, a reaction must occur at a reasonable rate for it to be useful. If you take, for instance, an example, say 4 tons of, let's say, ammonia is produced by a company annually, to say. Now, what you have to understand is that ammonia is not produced by following the inexpensive methods where the reactants of nitrogen and hydrogen are used because they are cheap, and they're readily available. You would find that this is not mostly used because thermodynamically this reaction could be favorable at a certain temperature, but the process or the reaction rate of this is quite slow. So we need to learn how to study how fast or slow the reactions will be. Anyway, in a nutshell, I can conclude to say that chemical kinetics is just the study of reaction rates. Not just reaction rates, we also study the factors that affect these reactions. Also the mechanisms I also studied. So chemical kinetics is simply a branch or a field in chemistry that studies reaction rates, the factors that affect the rates of reaction, and the mechanisms. I hope you understand. Alright, so it's time for us to move on to the first aspect of chemical kinetics. And that first aspect of chemical kinetics is one of the most important aspects. And this aspect is known as the reaction rates. So now, what is a reaction rate? Or in simple terms, what is a rate? So now, a rate is simply what we call the change in the concentration over a period of time. The change in concentration over a period of time is what we call the rate. So rate is equal to the change in concentration over the change in time. It's quite simple to understand. The change in concentration over the change in time. Now, what are rates measured in? Now, rates are measured in what we call molarity per seconds, okay, which is capital M/M. So they're measured in what we call molarity per seconds. When you talk about molarity, you're talking about the concentration. If you talk about seconds, you're talking about time. So the symbol will just be capital letter M/S. So it's a symbol for concentration per time. So you need to put this in mind. So the rates are measured in molarities per what? Seconds. Wonderful, I hope you understand. But don't forget, the rate is equal to the change in concentration of either the reactant or the product over the change in time. Alright, let's move on. Say you have something like A plus 2B producing AB2. Now, rates can be measured with respect to either the reactants or the product. So if we take respect of reactants, say A, the rate of A will be equal to the minus in the change in the concentration of A over the change in time. Then if you look at the rate of the reactant, which is B, its rate, which is of B, will be equal to the minus change in concentration of B over 2 change in what? Time. I hope it's clear. Then if you take it in terms of the product, it's the same procedure. The product AB, this will be rate AB2 is equal to the positive change in the concentration of AB2 over change in time. So these are the rates of this reaction. Now most of you are wondering, why is it that the rate of A and that of B are having a negative sign? Now this is because of one important point. Rates of reactants have a negative sign because we want to know how fast or slow a reactant or the reactants are disappearing or being consumed. That is why it's negative. Now the rest of the product have a positive sign because we want to know how fast or slow the products are appearing. Don't forget this. It's quite an important point. Okay? Now remember this, the reactants will always be negative and the products will always be what? Positive. Wonderful. Now there's a stoichiometric relationship of these things. Say you have A plus 2B producing C. Now what you have to understand is that the relationship of this equation here is that rate A will equal to rate B and rate B will equal to what? Rate C. Okay? So what is the rate of A? It's going to be minus change in the concentration of A over the change in time, being equal to the minus change in concentration of B over 2 change in time, being equal to the plus change in concentration of C over change in time. So this is the stoichiometric relationship of a reaction. I hope it's clear. Now, what you need to understand is that the relationship is very, very paramount to know. So let's do one last example of a relationship. Suppose we have, say, 4A plus 2B producing 3C. So how is going to be the relationship? We're going to say rate A is equal to rate B, and rate B is equal to rate what? C. So what is rate of A? Minus change in concentration of A over 4 change in time. Rate B minus change in concentration of B over 2 change in time, being equal to plus change in concentration of C over 3 change in time. If you did this, then you're correct. Now, let's try and understand the problems that we might come across. Remember, rates are measured in molarity per second. Molarity is a concentration. So rates are measured in concentration per seconds, which is symbolized, just a quick reminder, as M/S. Alright, let's try and look at examples. Alright, so let's begin with example number 1. Alright, so now example number 1, let's try and find the solutions. So example number 1 says, consider the reaction that we have. So A2 plus 3B2 produces 2AB3. Now if the rate of A is minus 0.750 molarity per minute, then what will be the rate of B2 and AB3? So before we even find the rate, let us change the rate of A into the units of rates. Remember, the units are molarity per second. So rate A should be in molarity per what? Second. So how are we going to change that? So we say, okay, rate A is equal to minus 0.750 molarity over how many seconds are in a minute? Yes, 60 seconds. So if you get your calculator and punch this, what is 0.750 divided by 60? So 0.750 divided by 60 will give you the rate, sorry about that, the rate of A being equivalent to negative 0.0125 molarity per second. So that's the rate of A that we'll be working with. Alright, so let's try and find A. Let's try and find the rate of B2. Remember, the relationship would tell you to say the rate that you have, which is rate A, because that's the only rate you will use to find the missing rates. So rate A should equal to rate B2, and this should equal to what? Rate A, B3. But now we're interested in finding rate B2. So we say, therefore, rate A should equal to rate B2. Now you have rate A, isn't it? Let's try and find rate B2. So now what is rate A? Rate A is going to be the change in concentration of A2 over the change in what? Time. And this is equal to, now you don't really have to put the minus if you want, but anyway, it's fine. So minus change in concentration of B2 over 3 change in time. So now change in concentration of A2 over change in time has already been given. So let me just rewrite this. So minus change in concentration of A over change in time being equivalent to minus change in concentration of B over change in time. Alright, so now what is change in concentration of A over change in time? That's the rate of A, isn't it? So the rate of A is minus what is given, which is 0.750. That was molarity in what? Molarity per minute. But this was not what we found. We found the value of this in molarity per second to be something else. We found it to be what? We found it to be minus 0.0125. Now this is equivalent to, it's supposed to be a 3 there, equal to minus change in concentration of B over change in time, 3 change in time. Now what you have to bear in mind is this: anything written as a change in concentration of something, either the reactants or product, such as B in this case, over change in time, is called the rate of that particular reactant or product. So which means that this gives me rate B. So wherever I see this, I just change it into what? B. So I have minus 0.0125 being equal to minus, I'm having 1 over 3 here, times this part, which is change in concentration of B over change in time. Mathematically, we're allowed to do that. So now this is minus minus minus, because we found it to be a negative, if you can recall. So this will end up being a positive 0.0125 being equal to minus 1 over 3. Now this is rate B, so we just say rate B. So for us to find rate B, we'll just say 0.0125 being equal to minus rate B over 3, and then after that cross multiply. This means that you have minus rate B being equal to 3 times 0.0125, then minus rate B is equal to, what is 3 times that value? You will end up having 0.0375. Because of the minus, divide both sides by minus 1, and therefore rate of B be equivalent to minus 0.0375 molarity per second. And that is your final answer. Alright, so let's try and solve for the other one before we move on to another example, because we have another example this side that we have to look at. So that's how we find the rate of B2. Let's try and find the rate of AB3. So since we've given the rate of A, we can relate the rate of A to the rate of what? AB3. If you look clearly here, the rate of B being the reactant, is negative. So don't forget to show the negative on the reactants. Now, here we're looking for the rate of the product, which is AB3. So now, let's try and mimic this. So let's find the rate of A. So minus change in concentration of A over the change in time is equal to plus the change in concentration of A, B3 over 2 change in time. So you can put this as minus change in concentration of A over change in time is equal to 1 over 2 times change in concentration of A, B3 over change in time. So now what is this called? This, remember, change in concentration of A, B3 over change in time is equal to rate, yes, AB3. Then change in concentration of A over change in time is equal to rate A. So minus rate A being equal to 1 over 2 times rate AB3. So now what is rate A? Rate A has been found to be minus 0. What did we find? Remember, we found something, isn't it? We found our answer to be 0.0125 in molarity per second, not the one in molarity per minute, is equal to rate AB3 over 2. So this just say, okay, we can say over 1, because this will just be positive 0.125 over 1 being equal to rate of AB3 over 2. So you do a cross multiplication and you have rate AB3 being equal to 2 times 0.0125. And then if you multiply 2 by what you have there, you will have the rate of AB3 being equivalent to 0.025 molarity per second. I hope it's clear. The moment you learn how to mimic this, you will be very, very safe. Remember, the rate of a product will always be positive, and that of the reactants will always be what? Negative. Alright, that's wonderful. Let's try and look at another example. Maybe we can understand this clearly. Alright, so we have 2H2 plus O2 producing 2H2O. If O2 is decreasing at minus 0.23 molarity per second, at what rate is H2O increasing? So we're trying to compare the rate of O2 and H2O. So our interest is rate O2 being equivalent to rate H2O. Now if you look at the rate that has been given, which is the rate of O2, we already have it in what? Molarity per second. So there's no need for us to convert. So we'll just take it the way it is. So now let's find the rate of O2. So it's minus change in the concentration of O2 over change in what? Time. Being equivalent to plus change in the concentration of H2O over 2 change in what? Time. So remember, minus change in concentration of O2 over change in time being equal to 1 over 2 times change in concentration of H2O over change in what? Time. I did make mention that change in concentration of H2O over change in time is rate of what? H2O. And change in concentration of O2 over change in time is equal to what? Rate of O2. So this is going to be minus rate of O2 producing 1 over 2 rate of H2O. What we want is the rate of H2O. So the rate of H2O should be the subject of formula. So we say minus, what's the rate of O2? It's minus 0.23 and is equal to rate H2O over what? 2. If you do a cross multiplication, you have rate H2O being equivalent to 2 times, because it's going to end up being a positive 0.23. Now if you use your calculator and find the rate of H2O, you say 0.23 times 2 will end up giving you what? 0.46 molarity per what? Seconds. And this is the rate at which H2O was what? Increasing. Alright, this is wonderful. If you get the point, then it's very, very nice. Let's look at the last example. The last example, if you can hear any noise, just ignore it. Yeah, just ignore it. So, let us find the last example, which should involve a bit of something less complex. But remember, the stoichiometric relationship is very important. If you have, say, A2, just a quick reminder, plus 3B4 producing maybe something like C. Remember, the relationship will be rate A is equal to rate B, which is equal to rate what? C. This will be minus the change in concentration of what? A2 over the change in time being equal to minus the change in the concentration of B4 over 3 change in time being equivalent to plus the change in concentration of C over change in what? Time. This is a very important relationship that you have to know. And every time you've been given one rate and you've been asked to find another rate, remember to only use the one you've been asked to find and the one given. So if I was given that of A2 and I'm asked to find the one for B4, I'll only compare A2 with B4. If I've been given A2 and C, I'll just use A2 and C. If I've been given C and B4, I'll just compare B4 and C. Remember that. Alright, let's look at another example. Now, N2 plus 3H2 will give you 2NH3. So this is a Haber process, formula for Haber process for ammonia. Now, if the rate of appearance of ammonia is given at an instant in time as 5.7 times 10 to to the minus 3 molarity per second. What is the rate of disappearance of hydrogen? So use what you've been given. You have ammonia and hydrogen. So let's get the rate of ammonia and the rate of what? Hydrogen. So the rate of hydrogen is the solutions. So the rate of hydrogen, which is H2, is related with the rate of what? Ammonia, which is NH what? 3. So the rate of hydrogen will be the negative change in the concentration of H2 over 3 change in what? Time is equivalent to what? The positive change in the concentration of NH3 over 2 change in time. Now remember, this can be separated as 1 over 3 times change in the concentration of H2 over change in time being equal to 1 over 2 times the change in concentration of NH3 over the change in what? Time. So just a quick reminder, change in concentration of NH3 over change in time gives you the rate of NH what? 3. And the change in concentration of H2 over the change in time gives you the rate of what? H2. So in short, you have 1 over 3 of rate of what? H2 producing 1 over 2 the rate of what? NH what? 3. So be mindful of this. Now we're interested in the rate of disappearance of what? Hydrogen. So we need to make the rate of hydrogen the subject of the what? The formula, isn't it? So be mindful of this. Having negative 1 over 3 rate of H2 being equal to 1 over 2 rate of NH what? 3. Let's try and do the algebra. So let's make what we want the subject of formula. So we want the disappearance of what? Hydrogen. So let's find the disappearance of what? Hydrogen. So I have 1 over 3 rate of what? H2 being equal to 1 over 2 rate of what? NH what? 3. So let's make the rate of H2 the subject of what? The formula. So what do? We can multiply both sides of this by negative what? 3. So you can have negative 3 over negative 3. Let me not say that. Let me say we'll have negative 3 times negative 1 over 3 times the rate of what? H2 being equal to negative 3 times 1 over 2 times the rate of what? NH what? 3. So negative 3 times negative 1 is positive 3 over 3 times the rate of what? H2 being equal to negative 3 over 2 the rate of what? Ammonia, which is NH3. This cancels out and you end up having the rate of what? H2 being equal to minus 3 over 2 the rate of NH3. Now, what was the rate of NH3 in the initial question? Remember, it says if the rate of appearance of ammonia at a given instant in time is 5.7 times 10 to the minus 3 molarity per second, what would be the rate of disappearance of hydrogen? So that's the rate of what? That's the rate of ammonia. So it's going to be minus 3 over 2 times what? The rate, which is 5.7 times 10 to the minus what? 3. Now, if you try and compute what you have, minus 3 over 2 times 5.7 times 10 to the minus 3. If you compute this, what are you going to end up having? Now, you end up having the rate of H2 to be equivalent to minus 8.55 times 10 to the minus 3 molarity per second. That will be the rate. Now, if you look close, hydrogen is a reactant. That's why we end up having a negative sign on the rate of what? Hydrogen. I hope this is clear. This part of chemical kinetics is very, very important to know. The moment you understand this, you'll be very, very safe. Alright, so don't forget to like and subscribe. This is Mr. Hussein. If you have any questions concerning this topic, kindly reach me on WhatsApp on the number that I'll put in the description or the number that's above. As you can see, the top bar has my name and the contact. You can reach me there and I'll answer. Alright, thanks for watching and let's try and push for that A+.